Let us now look at question 3 from 2022 November Physical Sciences paper 1, which is vertical projectile motion. Question 3, a ball is thrown vertically upwards. What do we need to know is that when a ball is thrown vertically upwards, it will decrease in velocity. Now from the top of a building, which has a height of what? Of 25 meters. The velocity of this ball now is 12 meters per second. On its way down, the ball passes a door which has a height of what? Of 1.9 meters, and then strikes the ground as shown in the what? In the diagram below. Let us look at our diagram now to see. Now you can see that the ball was thrown vertically upwards from the top of a building. The velocity is given as what? As 12 meters per second. The ball reaches its maximum height. What do we know about the maximum height? Is that the velocity is what? Is 0. And therefore the ball will then turn. As it reaches the same point where it was thrown, we are going to have 12 meters per second. But remember here, you must choose direction. If you choose up as positive, down is going to be negative. Let us then look at our question here and see if we can answer these questions. 3.1, it says define the term free fall. What do we need to know about free fall is that in a free fall, this is a motion. A free fall is a motion in which an object or of an object, so it is a motion of an object under what? Under or which the only force acting is the force of what? Force of gravity. The only force acting is the what? Is the force of what? Of gravity. Is the force of gravity. You can answer this question by saying that the only force acting is gravity, or you can say that it's a motion under the influence of what? Of the force of gravity only, and therefore you get your 2 marks. We then move now to calculations. For these 3 marks here, how do we then get full marks? We are told to calculate the time taken. So we're looking for the time now. But which time are we looking for? For the ball to reach what? Its maximum height. Remember I said something about the maximum height, that the maximum height, the VF is what? Is 0. So which direction are we choosing now? We must then decide to say we are taking positive as what? As upwards. So we are choosing positive as what? As upwards. So what do we have here? We go to our formula sheet. We then choose the correct formula because we do have VI, which is what? 12 meters per second. We do have VF, which is what? 0 meters per second. And therefore, what are we looking for? Remember, we have the gravitational acceleration, which will be 9, but remember, negative 9.8 meters per second. Why negative? Because we have chosen upwards as what? As positive. Therefore, our formula is VF equal to VI plus acceleration change in time. We have 0 this side. We do have 12 as our VI plus negative 9.8. We are looking for the what? For the time. And therefore, what do we have here? We can say 9.8 change in time. In fact, it is 9.8 change in time. It is now going to be positive. Why positive? Because I've taken it to the left hand side. So change in time, and therefore we have 12. We divide by what? Both sides by 9.8. We divide by 9.8. What is our change in time then? We go to our calculator. We say 12 divided by 9.8. What is our answer then? We are getting 1.22. So our time is 1.22. Don't forget that we measure time using what? Using seconds. That's how we then do question what? Question 3.2.1. Let us now look at 3.2.2. We are now calculating the velocity which the ball strikes the ground. So we are looking for the velocity which the ball strikes the ground. What we can then do here is to look at our diagram. Our diagram, we're at point A, we're at point B, we're at point C, we can create point D here. This is where the ball was projected. Maximum height came to the very same point where it was projected, and then now to what? To the final destination, which is the what? The ground. So let us look at this now. We do have the velocity here as what? As negative 12 meter per second, because it is going down. So we can use C as our reference point to what? To D. What else are we given? We are given this height here. The change in Y is what? Is 25 meters. We therefore go to our formula now. We must always avoid the formula that has time, because we don't know the time from C to D. So we can say VF squared equal to VI squared plus 2A change in Y. Do we know the VF squared? No, we are looking for the final velocity, which is VF squared equal to VI squared is the same as what? As negative 12. Negative 12, I can just put it as 12 because I've squared there. It will cancel the negative. So 12 squared plus 12 squared, so let me say minus 12. And therefore, we have 2. This is minus 9,8. And therefore, the change in Y is what? Is also minus 25. All right. We go into our calculator now. We just punch everything that we have. 12 squared, 12 squared, 12 squared, it will give me 144. 12 squared will give me what? 144. And therefore plus and negative will give me positive. So now what am I looking for? 2 times 9,8 will give me 19,6. So I know now that I can say 19,6 times what? Times 25. What am I going to get here? I'm going to get 4. I'm going to get 4 what? 490. I have 490 here, and therefore this is VF squared. Now what is 490? What is 490? 490 plus 144. And therefore I get here, I have 634. And therefore VF squared, I can square both sides, and therefore my V equal to, what is the square root of what now? The square root of 634. And therefore this will give me what? Velocity is 25. We go back to our calculator so we can take the correct answer there. 25,2 or 25,18. So we can say 25,18. So this is 18. It's what again here? It's meter per second. And then meter per second. Don't forget that it's a vector quantity. So we can say what now? We can say downwards. That was 3.2.2. We now look at 3.2.3. We are tasked to calculate the time it took the ball to move from the top of the door to the what? To the ground. Maybe to refresh our memory, we need to look at the diagram as well so we can see what's happening. On the diagram here, this is the top of the what? The top of the what? Of the door. However, the total displacement from the top of the building was 25. So we can then calculate the difference between the top of the door and the top of the building. So we can say that change in Y equal to 25 meters minus 1,9 meters. And therefore, if we go to our calculator then, if we go to our calculator and say 25 minus 1,9, 25 minus 1,9, 1,9, what do we then get there? Our answer is 23,1. So we can come and say 23,1 meters is my what? Is my change in displacement from the top of the building to the top of the dome. So we have the velocity from point C. We don't have the velocity at the top of the what? Of the door. It is advisable to calculate the velocity at the top of the door. Therefore, we can find the time because we know the what here? We know the final velocity. Let us go and do just that. Which formula can we then use? We can say that V f squared final velocity equal to vi squared plus 2a change in y. Do we know the final velocity? That is what we are looking for at the top of the what? Of the door. Therefore, here we have what? We have 12, which is squared, plus 2. Remember, down is positive. And therefore, we are going to have what here? We are going to have minus 9,8. And then the displacement here can't be 25. It must be minus 23,1 because we are looking for the difference between the two. And therefore, from here, we go to our calculator, and therefore we punch. We see a negative here and a negative this side. This would mean what? The answer would be positive. So we can just punch from here to say 12 squared. We have done this before. It's 144 plus, we know that 2 times 9,8. This is going to give me 2 times 9,8. 2 times 9,8. Let's just fix that here. This was negative. 2 times 9,8. This is going to give me minus 19,6. Minus 19,6. So let's look at that. Minus 19,6. And therefore now, how do we then get that 19,6? So we can come and say 9,8 times 2. It will give us 19,6. So there's our 19,6 here, which is negative, and therefore negative and negative positive. So here I can say 19,6 times, to be positive this one, 23,1. Therefore we just come here and add everything that we have here. Or we can say 144 plus, what do we get when you say 19,6 times 23,1? What is our final answer then? We have 452,76. So it's 452,76. We add the 2. We just come to our calculator because our answer is there. We say plus 144. Plus 144. 144. And then our answer now becomes 596,76. So what do we have there? We have 596,76. Don't forget that we have v squared here, and we also have v squared here, and vf squared here. Our vf squared here, we just square root there, 596,76. So our vf will then be, we go to our calculator. If we go to our calculator now, we will say square root of what? Square root of 596,76. What do we then get? We get 24,428. So remember to round off here to 2 decimal places. So meaning that this will be 24,43. So this will become 24,43. This is meter per second. And remember, this is downwards. And therefore, we're looking for time. So we are not done here. We're looking for time. So we can say Vf equal to Vi plus a change in time. Do we know our Vf? We did calculate our Vf in question 3 point. This is 25,18 and it's negative because it's downwards. So we do have our Vf there, which is what is the same as 20 what? Negative 25,18 equal to Vi is what we just found here, which is negative as well. So it will be negative 24,43 plus negative 9,8, and then changing what? Changing time. All right, so when we have this, we can take 24 to this side. It's allowed to do that. And therefore, what do we have when we take 24 to that side? We can go to our calculator and say 25,18. 25,18. So it's 25. Remember, it's negative. So we'll say negative 25,18 This one will become positive 24,43. And therefore, what do we have there? We have a negative answer as 0, which is negative 0,75 equal to, what do we have again here? Minus 9,8. Changing what? Changing time. We divide by 9,8 both sides. What do we then get? So change in time. What are we going to have here? Change in time is the same as negative 9,8, negative 9,8, right? We divide by a negative 0,75. In fact, here, because we are dividing by 9,8, we are supposed to say negative 0,75. The comma is not there. Negative 0,75. We divide by a negative 9,8. And therefore, our time there is going to be 0,76. We can round it off to 0,8 seconds. And that's how we do question 3.2.3. You get full marks there on time. The reason we use two equations here is because we do not have the what? The velocity at the top of the what? Of the door, which we have calculated here. So once I have the velocity, it is easier for me to look forward now or calculate for time. Let us go to our last question, which is 3.3. With 3.3, what we are tasked to do here, we have to draw a what? A velocity versus time graph. A velocity versus time graph. But we must be careful here. We have to look at what we are asked, because we don't have to just draw for the entire motion. They will clearly indicate what we are supposed to draw. So let's go through this question. It says draw a velocity versus time graph for the motion of the ball from the moment the ball is thrown upwards until it strikes the what? The ground. Okay, what are they looking for? They are saying that we must use the ground as what? As zero reference. Okay, so clearly indicate the following in a graph. The first thing we must indicate is the velocity with which the ball was thrown, and then the time taken for the ball to reach the maximum height, and the velocity in which the ball strikes the what? The ground. All right, so now what we have here is we need to draw the velocity versus time graph. The first thing that you must do, you must have a title. What is our title? Now we were told that is what? Is velocity versus what? Versus time. Velocity versus time. And therefore, what do we have? What must be on the x-axis and what must be on the y-axis? So our time should be on the x-axis, and then the velocity must be on the y-axis. So now I have this, then I have this here, because now on the y-axis is velocity, so I must indicate velocity. What is the unit measurement for velocity? Is meter per second. All right, and therefore here I have what? I have time. We use what? We use seconds on time. Now we were told that we must draw the velocity which the ball was thrown upwards. We know that velocity. The velocity is what? It was 12. And it can't be negative. It was 12. And therefore now, the ball, as the ball was vertically projected upwards, it means that it decreased in what? In the velocity. So this will be my maximum height. Why? Because I see that my velocity is what? Is 0. Now the time it took, we have calculated this one as 1,22. So this is the time here. And then the ball then turned and moved vertically where? Downwards. And therefore the maximum velocity it reached when it reached the ground here, we got the answer here. We can just verify it. Our answer was 25,18. So we have to indicate that on the graph. We have 25,18. So I have what here? 25, what? 18. That's the velocity versus time graph. This is the point it was projected vertical upwards. This is the maximum height. How do I know that? The velocity was 0, and therefore this is what is the velocity, or the final velocity that the ball had when it hit the what? The ground. That's how we draw a what? A velocity versus time graph. And of course we use this type of a graph because we chose positive as what? As upwards. Positive as upwards. If you have chosen upwards as positive, this would mean that your negative will be downwards. So the graph will be slightly different from what I've drawn here. So you are welcome in the exam to choose downwards as negative. You are welcome to also choose downwards as what? As positive. This is how we are supposed to draw the graph. This is how you're supposed to get full 3 marks. So how do you then mark this graph? We are going to mark for the point that you have here, the shape of the graph, and you must have the title. On the x-axis, you must have time, and on the y-axis, you must have what? Velocity. That's how we answer 3.2.4. This is how you then answer 3.2.4. That's how we draw a graph.